In the got it problem, we have another word problem. One satellite radio charges $10 every month and an activation fee of $20. A second service is $11 plus the $15 activation. For what number of months is the cost the same? Well, since we're learning by graphing, we're going to say number 1 and number 2, and we're going to graph each one. What is changing about the first radio? In the first radio, we have $10 every month. Since that's the one that's going to be like varying, we put it with the variable, plus the activation fee of $20. So we've made our equation. The second problem, we have $11 every month and our activation fee of $15. Be very careful when you go to graph this, because the slopes are so similar to each other, you may make sure you count very, very, very well. You might want to even make an XY chart and figure out when these two will be the same. If you want to take a guess at what the X and the Y value of them being the same is. What I'm going to do is skip over this problem. I'm going to tell you the answer.
Mr. Hospital, please come to the office.
Sorry. I'm going to tell you the answer in a little bit at the very end, and then you can see how well you've done. Alright, now we're going to kind of get into some special cases and some vocab, okay? A system of equations that has at least one solution is what we call consistent. A consistent system can be independent or dependent. A consistent system that is independent has one solution. For example, in problems 1 and 2, they are consistent and independent because they had an answer and they had one answer. But a consistent system that is dependent has infinite solutions. And then we have one more type. A system of equations that has no solution is what we call inconsistent. If you're a visual person, it might be beneficial for you to see it like this. There's consistent versus inconsistent. Okay? Consistent, you can have independent or you can have dependent. If it has an answer, we call it consistent. If it has no solution, we call it inconsistent. If it has an answer and there's only one answer, that means it's independent. If it has an answer but it has infinitely, watch this symbol, it's like a figure 8, infinitely many solutions, we call it dependent. So if you're a visual learner, I'm hoping that this little chart down here is easier for you to understand than the paragraph up there. Let's go on to problem 3 and see some special cases. What is the solution to each? Use a graph. Look at part A. Right away in part A, remember I told you when we were reviewing some of your Algebra 1 skills, how essential it is that you know how to solve this system for the variable y. So what I got to do is I'm going to put a number 1 beside this, and we're going to practice solving this system for y. Because that is how to graph, guys. That's the best way to graph. First thing, add an x to both sides. The 2 and the x cannot be put together because one has a variable and one does not. So when we move the x over, we get 2y equals x plus 2. Divide everything by a 2. That becomes y equals, be very careful here, look, there's a 1 in front of the x. So this becomes 1/2 x. Don't make it 0.5. Plus 1. I can now graph this equation by going to my y-axis and going up 1, because that's the y-intercept. And then I use my slope. Look, it's already a fraction, 1 over 2. I go up 1, right 2. Up 1, right 2. And then I can do the same thing on the other side. Connect using a straight edge. and you'll have a straight line, hopefully. Now let's look at number 2. The second equation is already solved for y. That should make you pretty happy. But what do you notice about this equation? It's the exact same. At least I hope you notice that it's the exact same. Well, if it's exact same, guess what? Your line, no doubt, right? The exact same. Your line's going to be the exact same line. If this happens, it's like asking this question. When does it meet? And that might sound kind of funny, right? Because it meets everywhere. Well, in math, we say it meets infinitely. So our answer is infinitely many solutions. And we can even go on to say, if we want to, that means it's consistent and that it's dependent. And that comes from the previous page. Let's look at part B. Part B, we have not the same equation, so we're actually going to have to graph both of them. The top one, go up 2 and make a dot. Since I already solved, I'm just going to do it just straight in a row. M is 2 over 1, and B is also 2, because of the 2 here and the 2 there. So you graph B first by going up on your y-axis, up 2, and then up 2, right 1, up 2, right 1, and then down 2 left, down 2 left, down 2 left. Okay? Get your straight line, connect it together, and you have your first equation graphed. Your second equation, your slope is again 2 over 1, and your y-intercept is negative 1. So that means you're going to start down 1, and your slope from that point goes up 2, right 1, up 2, right 1, up 2, right 1. And you should notice something happening. It's never going to catch it. So let's use our real math words. It's never going to intersect. Right? Because the slopes are the same. If you have two things that have the exact same tilt, they're never going to touch each other. Look at those two lines. They will never meet. A word for that is parallel. Right? Well, if they're never going to meet, let me ask this question. When will they meet? They will never meet. So this is a no solution. It sounds weird, but the answer to this problem is no solution. In other words, it's inconsistent. Number 3, we can do again. But what I'm going to point out here to you, are you ready? Take a pencil and split these two apart from each other. Okay? On part A, write this up here. On part A, they have the same slope, right? And they also have the same B. That implies that they are the same. That means they're the exact same lines. You don't even really have to graph them. You know it's going to be infinitely many. Automatically, even without graphing, right? Look at part B. In part B, they do have the same slope. I hope you agree. Each slope is 2 over 1. But they had different y-intercepts. If this happens, there will be no solution always, because the lines will never touch. Let's use that concept down on the got it. If you want to graph it, you can, but I'm going to try to shorten this up for you. Part A, you ready? If you want to graph it, please do. Equation number 1 on part A. The slope is -1. I hope you agree. The y-intercept is -3. I hope you agree with that. Okay, so that was equation number 1. Equation number 2. The slope is -1. The y-intercept is 5. What do you notice about these? Can you see that they have the same slope? Can you see that they have different y-intercepts? Do you remember from part B above that if that happens, there will always be no solution? And let me show you if you're concerned. I did graph them on another set here. That's what they look like. They will never meet. Let's move on to part B. Part B, we have 2 equations again, 1 and 2. In equation number 1, the slope is 3. And the y-intercept, oops, sorry, not 2, I didn't mean a 2. And the y-intercept is -3. Now let's look at equation number 2. Now look how I'm writing equation 2, because guess what? We got to solve for the letter y. Divide by 3, divide by 3, divide by 3. Y equals 3x minus 3. You must solve for y first. Absolutely, okay? Your slope now is 3/1, and your y-intercept is -3. Take a moment and look at these. Compare them. Can you see that they have the same slope? Can you see that they also have the same y-intercept? If that happens, your answer is infinitely many solutions. I did graph them on another piece, just to double check, and you can see they were the same exact line. Moving on is your summary page. If you're a picture person like me, this is very helpful. Okay? If your lines cross one time, okay, if they cross one time, your important words is that they have different slopes, and who cares about the y-intercepts? They have different slopes. They'll cross once. Okay? The equations are consistent and independent. Now let's say you graph them and you get the exact same line. That means there are infinitely many. Your words for that are consistent and dependent. They have the same slope and the same y-intercept. Okay, so if you're used to seeing me write it like this. Okay? Maybe over here we should do that too. If they have one solution, they just have different slopes. That's all. Doesn't matter about the y-intercept. If they have different slopes, they'll have one solution. And then we have no solution. No solution, you only have one word to remember, that's inconsistent. And they have the same slope, different y-intercepts. You're used to seeing me write it like this. That's the lesson in a nutshell. Please, if you have any questions, go back. You can re-watch your problem. Write down any questions that you have. Give me a moment and I'm going to give you that answer to that other problem that I was telling you about with the cell phones. The answer to this problem, what months will the cost be the same? If you did choose to do an XY chart, you should get that at 5 months, they will be the same cost. If you need some extra help after that, please let me know tomorrow in class.